me share. Now look at this system. This is a system where you will find different forms of energy. Okay, so let me give you a brief idea about this simulation. Okay, so you will find here, these are the symbols what we are having. E stands for mechanical energy. Sorry, the color stands for that. Okay, so this particular color, a gray color, stands for mechanical energy, a blue for electrical, the red for thermal, yellow for light, and green for chemical. Okay, so these are our different colors for energy: mechanical, electrical, thermal, light, and chemical. Okay, so we start our system. Now if you look at this, this is a source of flowing water. This is our turbine. Then we have connected one end, and here we are having a container, and there is a coil you can see here, okay, which is just working as a heater. Okay, now see what actually happens, how the energy conversion is taking place. So I allow the water to flow. See, so as you find that the water is flowing, so the flowing water is falling on the turbines. Exactly. So if you look at this particular mechanism, the first part of our mechanism, this part of our mechanism, you will find that this is nothing but this is our this part of mechanism, this part of mechanism, this part of mechanism is, which I have just highlighted. This part of mechanism is my hydroelectric power. Exactly. What is this? Our hydroelectric power plant. Because what happens in the hydroelectric power plant, so there we are having water stores in the dam, and the water is allowed to fall from a height, and that flowing water has, see, understand, that flowing water has kinetic energy, and then obviously it has mechanical energy because it has potential as well as kinetic energy, and that's why it is said it's having a mechanical energy. And then that mechanical energy is that flowing water is falling on the turbines. Due to that, this turbine rotate, and due to the rotation of the turbine, there is a conversion of mechanical energy into electrical energy. So you will find that the flowing water has mechanical energy, and then this system which I have shown you with the red border, this system is converting the mechanical energy into electrical energy. Okay, then we proceed. Now what is the next? Then what happens here, you'll find that the electrical energy, now the electrical energy is used to heat up this coil. So you will find there's a conversion of electrical energy into thermal energy. Exactly. So you will find how the energy conversion is taking place. This is this part of the system. If I highlight this part, okay, this is nothing but this part of the system is as good as your heater, okay, which is used in your washrooms to heat the water. Okay, so what is the energy conversion in heater? So you will find in heater the energy conversion is from electrical to thermal. Okay, so understand there are two conversions taking place. Here we have the mechanical energy which is getting converted into electrical energy, and then the electrical energy is getting converted into thermal energy. Are you getting it, class? So we are having two sources. We are having a hydroelectric power plant, and then we are having a heater. So my hydraulic. So if you look at from end to end, we are having mechanical energy, and the mechanical energy is getting converted into thermal energy. Let's talk about another system in this. Now here, instead of taking this, if I take a, okay, so now look at what happens here. Okay, now we are already aware about this end, but we'll talk about this one, only the one which I have highlighted with a red border. So here you will find we are having electrical energy, and look at this. Do you know what is this? This is not merely a bulb. Okay, you can call this as a filament bulb. What we can call this? You can call it as a filament bulb. So look at the energy conversion that is taking place here. Okay, so you will find it is electrical, and then you will find that electrical is converting into thermal, and then from thermal we are getting light. So see here, because the what the filament is doing, you will find that the electrical energy is converting into thermal energy. You will find that all these electrical energy is first getting into thermal and then into light. So if you want to write the energy convergence, please write down the energy conversion of a filament bulb. So you will find it is electrical energy. Electrical energy is getting converted into thermal energy first. And then the thermal energy is getting converted into light energy. So this is the energy conversion which is taking place in a filament bulb. Okay, because the electricity is getting converted to thermal and then to the light. That's why you will find, students, that the filament bulb has less efficiency. Okay, what the filament bulb has, it has less efficiency. What is the meaning of the word efficiency here? Efficiency means if we supply 100 a particular amount of energy to it, so how much of that energy we have supplied is being converted for its fundamental purpose. Now what is the purpose of a bulb? The purpose of a bulb is to give us light energy. Okay, but you will find if you are using a filament bulb, then what happens, you will find that the electrical energy is first getting converted into thermal energy, and the thermal energy is getting converted into light energy. Due to that, you will find that this efficiency is very less. The efficiency of a filament bulb is around 40%. What's the efficiency of a filament bulb, beta? It is around 40%. Why is it so? Because assume you supply 100 joule of energy to a filament bulb. Out of that, only 40% of the energy will be converted into light energy. The remaining will get converted into heat energy. And what is the reason? So you will find that the energy conversion here is first from electricity to thermal and then to light. I hope you are getting it, beta. Please acknowledge if you are getting it, and if you have any query as well. Okay, but now I will change the system. See, I'm changing it now. I go to the traditional bulbs nowadays what we are using. It is called as CFL. Okay, now look at the energy conversion in CFL. Okay, the another type of bulb what we have. Okay, let's look at the energy conversion in this system. Okay, so you will find here the energy conversion is directly from electrical energy. You will find it's converting into light. What's the energy conversion? You will find the electrical energy is getting converted into light energy. Exactly. And as the electrical energy is getting directly converted, see, there is no conversion of electrical to thermal and then to light. It is directly converting electrical energy into light energy. Yes, some amount of light energy and little bit amount of heat energy is also there. But there is no conversion from electrical to thermal first. It is electrical to light directly or electrical to thermal directly. And that's the reason why you will find that these bulbs are having very good, a very high value of efficiency. The efficiency of this CFL bulb is somewhere around 90 to 92%. Okay, means if you supply around 100 joule of energy, out of that approximately 92 joule of energy will be converted into light energy. Exactly. That's the reason why nowadays we don't prefer to use a filament bulb, rather than we prefer to use a CF. this is our one more energy conversion. Then if I convert this end, and I go to the fan. So now look at the energy conversion. Now, what is the energy conversion taking place? So we have uh, mechanical to electrical, and here again from electrical to mechanical, because what we are having the air blowing. So what is the energy conversion in fans, beta? So the energy, please make a note of all these energy conversions. Huh? So the energy conversion here, you will find it is electrical to mechanical. I'm only talking about the end system here. This system is converting electrical to mechanical, because this is my electrical to mechanical. Okay, is it very clear, bachcha log? You can give your responses by typing by in the chat. Okay, chalo. So I think only Saujanya is understanding. Saujanya, Shravani, Swada, Arya. Okay, what about others? Please respond. Huh. Okay, now let's change the source of it now. This is my flowing water. So I hope how is the energy conversion taking place in the hydroelectric power plant. The same is the concept here. Now let me change this. Now what we are having? So we are having another fundamental primary source. What is that? So we are having sun. Now what is a sun? So sun is giving us light energy. Okay, yes, we know sun gives us heat energy as well, but we will focus on the important one. What is for our purpose is light energy. So we are getting light energy from sun, but if the light energy falls on the turbines, the turbine will not rotate. Exactly. I hope you are understanding this, that now the turbine will not rotate, because when the light falls on the turbines, it will not rotate. And due to that, you will find there is no further conversion of any energy. So this system is not a working conversion system. So what do we have to do? We have to use a medium through which my light energy gets converted into electrical energy. And which is that medium? So I cannot use turbines here to convert the light energy into electrical energy. Instead, I have to use my solar cells, solar panels. So see what I have done. So here I have installed a solar panel. Now what happens here? So you will find that when the light energy is falling on the solar cells, the solar cell is now converting the light energy into electrical energy. So you will find there is a conversion of light energy into electrical energy. So this mechanism is the functioning of a solar cell. So you can write down, please write down solar cells, how they work. So they convert light energy into electrical energy. And then again, further, we are using the same mechanism where we are having electrical energy converting into mechanical energy. If I use this one, then the electrical energy is converting to heat the water. Actually, this is what we are using solar panels. You must have seen at n number of places, you must have seen on the top of the house, the solar panels are being installed, and early in the morning, we use them to heat water. Exactly. So this is a mechanism here. We are having solar cells, which is converting light energy into electrical energy, and then the electrical energy is getting converted into heat energy to heat water. Okay, so this is one type of energy conversion, but this is not an efficient energy conversion, because whenever we have some clouds, I will add some clouds. So what happens? The ratio, the amount, the magnitude in which the electricity is generated will be less. And if there is almost clouds, okay, then we will find that this system will not work. Okay, so this is the drawback of our solar cells, that here it is going to work only during the daytime or when the sky is clear. If there is a cloudy, if it is cloudy outside or during the night time, then we will not able to use it. So now we are having another source. What I am having? So I am having, now this is the earlier mechanism. This mechanism, what I've shown, this was our hydroelectric power plant. This is solar cells, and now this one is our thermal power plant. Okay, you know what happens in thermal power plant, bachcha log? In thermal plant power plant, we are having big boilers. Exactly what we have. We have big boilers, and in that boiler there is water. And what we do, we heat the water. What we do, we heat the water, and as we heat the water in the boiler starts boiling, and it gives us and it comes out in a form of steam, which is nothing but mechanical energy. Exactly. So what we are having, now look at this conversion here. We are having heat energy getting converted into mechanical energy. But the problem is, if this mechanical energy is being placed on the solar cell or near the solar cells, this mechanical energy will not get converted into electrical energy. So what we have to do? So again, we have to go back to the traditional system where we are going to rotate the turbines. So this is my turbines, and what you observe? You observe that the heat energy is getting converted into mechanical energy. Then that mechanical energy is enough to rotate the turbines, and then the turbine is converting the mechanical energy into electrical energy, and then here we are having electrical energy getting converted into light energy. Okay, so see the energy conversion at each end. We start with thermal. Thermal is getting converted into mechanical. Mechanical is getting converted into electrical, and electrical is getting converted into light. So this is the energy conversion. Whereas this particular part of the system, this part of the system, this part of the system which I have highlighted with a red border, you will find this part of the system is my thermal power plant. So please write down thermal power plant. And what is the energy conversion in thermal power plant? So write down from heat to mechanical and from mechanical to electric. Write down the energy conversion in thermal power plant, from heat to mechanical and from mechanical to electrical. This is our thermal power plant. I hope you have copied it. Then here again I can replace it. I can replace it with the filament bulb, or I can replace it with a fan, because we require electrical energy for all these conversions. I can have fan, I can have the CFL bulb, or I can also have a filament bulb, or I can have a normal heater. Okay, but if I use a heater, it doesn't make any sense as such, but it doesn't, is how it works. Now we are having another one. If I take a filament bulb and sorry, the solar panels, and I am having another. What is that? So we are having a boy, and he is riding a bicycle. Okay, so now let's talk about a boy riding a bicycle. Okay, so what is the energy conversion? So let's start. Okay, so we observe that what we have in us, we have chemical energy. When we eat food, na beta, so that food is stored in our body. Okay, the food is possessing chemical energy, and what is happening? The chemical energy is getting converted into into mechanical, and then getting converted into heat. See, here you will find that the electrical getting converted into mechanical, and then it's getting converted into thermal. So you find there's an energy conversion. There's an energy conversion from chemical to mechanical and mechanical to heat, because when we do work, the heat is liberated from our body, and that's why we get tired as well. If you keep on cycling, you find that your body sweats as well. Okay, and this is because there is energy conversion from chemical to mechanical and from mechanical to heat. Okay, but what happens gradually? If we keep on cycling, gradually we will get tired. Exactly. We feel hungry. Why? Because the entire energy, the chemical energy in our body is getting used up, and then we are not being left with that much of energy that we can ride the bicycle. Okay, because if you want to do some work, we are already discussed. If you want to do some work, we require energy. So here, see, now he's not having any energy left in. So he's asking to feed, obviously. So what we have to do, we have to give him the food, and when you give him the food, then yes, again, then he's ready. He's having a lot of chemical energy. But can we further utilize it? Yes. For this rotation has to be converted to help the rotation of a turbine. Now look at the energy conversion here. A boy riding a bicycle. Now you will find a boy riding a bicycle. Okay, so you will find the energy conversion. Look at the energy conversion now. So what we have? So we have chemical. So the chemical is getting converted into first mechanical. And this mechanical energy, yes, some of them is getting converted into thermal. So we find that the chemical energy gets converted into mechanical. The mechanical energy here is getting converted into electrical, and then the remaining part of it, which we are already aware of. Okay, so this is how the energy conversion takes place. But now look at this process. It is a very slow process because the rotation of the wheel is going on very slow. So that's why the rate at which the energy is getting converted is also slow. Now I increase the speed and see what happens. So you'll find that the rate at which the energy conversion will take place will be very fast. Okay. And due to that, the energy conversion will take place more faster.